Hi, so we're going to take a look at parametric equations. Okay, this section we'll do in one day. The next section, 9.2, we're going to split over 2 days. But basically with parametric equations, you can get all kinds of different graphs. Right? So some of these are a lot more complicated than what we're going to look at. We might look at one like this end one. But yeah, this one in the middle, like the butterfly, that's pretty complicated to do. But how do these differ, say, from like functions we've done at the beginning of the year? Like, they don't pass the vertical line test, right? They're not functions, none of them. So you can have a parametric equation that is a function, okay? But a lot of times they do cross over themselves. Okay, so they don't pass the vertical line test. So we'll graph some things that are parametric, probably like line segments, circles, and maybe a few things that are curved, but you're not going to see any of these type today. Right? But kind of a little tease of what you can do with parametric. If you play around with it, you can have fun and figure out all kinds of things.
Is there any limits to what you can do?
Is there what?
Is there any limits to what you can do with that?
Nope. All right, so what ends up making parametric really different than what we're used to, which is y equals, is you have two functions per picture. Okay? You have one function that's going to graph the x coordinates, and you have a separate one for the y coordinates. So we've never seen that before. Right? So two separate functions. One function for the x's, one for the y's. I'm calling them f and g in this case. So f is the function that gives me the x values. G is what gives me the y values. And when we graph something parametrically, it's only over a certain interval. Parametric graphs don't go on forever. Sometimes they kind of loop around and they end back where they started. But even if we were sketching like a line or something, we usually don't. We just sketch a part of a line. Okay, we have like a line segment. Okay, so all parametric graphs have an interval over which we graph the ordered pairs. Okay. And if you make a picture of all those ordered pairs over that interval, we get what's called a parametric curve. Now, don't think that the word curve means it really always has to be curved. If we have a line segment between 2 points, that's a parametric curve. So it's not, strictly speaking, something that's arced or anything like that. Right? So the two equations that make up your sketch, those are called your parametric equations. Okay? You'll have one equation for your x's, and you'll have a separate equation for your y's. Okay? And when we go to the graphing calculator, you'll see the same thing. Okay? What I'll do is I'll bring up the calculator and show you what it looks like when you put it in parametric mode. Okay? And I'll put this back up. All right, so first thing you have to do is go to mode, and then we're going to change to parametric, which is right below radians and degrees. Now when you go to y equals, it's going to look a little different. Okay. For each sketch that you want to do, you have to give an x function and a y function. Okay. Two different functions. And together, the two equations we type in, those are going to be the parametric equations. And the variable, notice I used a t. If you go on your calculator and now you press the xt theta button, it's not x anymore. If you change to parametric mode, now this button is a t. Okay, so that's how you do your variable, same button. Okay, and that variable we call a parameter. The only reason, I don't know why they do it, it's called a parameter when you're working in parametric. And the parameter can change. Okay, I'll show you how we do that. Usually the parameter has a minimum value and a maximum value. And if you go to your window, you'll see there's a spot under window. Now to type in a minimum value for the parameter and a maximum value. in addition to your window left and right and your window up and down like we've always had. Right? So this Tmin, Tmax, and Tstep, those are all new. And they're all very important, especially Tstep. We'll talk about that. Right, so just kind of a different word you might see. If you have a curve defined by parametric equations, we call those equations, or we say that those equations give you a parametrization of the curve. It's kind of hard to say. So let me show you an example, and then I'll come back to that. These two equations give a parametrization of the curve, and we could sketch it. Okay? But that's what they are. These are parametric equations. T is your parameter. I is your interval. And you have a low value and a high value. It's kind of like a domain. Right, so we'll come back in a second and practice finding the endpoints of that curve. Okay, from the first slide, you can see curves can intersect themselves. And today we'll look at some things that are line segments. We'll look at circles. We'll look at maybe a spiral. It's all kinds of things we can look at. Okay, but what's important to understand about a parametric graph is it has a start point and it has an end point. Sometimes the start point and the end point are the same. Like when we sketch a circle. It might look like it ends where it starts, and that's it. Okay. Sometime in the case of drawing a line segment, the start point and the end point are not the same. Okay. Two different points. Does everyone have what's on the left? Okay. So usually you're going to have a parameter defined over a closed interval. Like in this example, 0 to 1. Okay. I'm just using it generically, A to B. Bless you. Okay, to find the endpoints, okay, one's the start, one's the finish for the curve. You have to use the two values that they give you. And they're going to give you two functions. Right, so what you do is you take A, whatever that number is, plug it into the formula that gives you your x's. Then take A, whatever number it is, plug it into the formula that gives you the y's. What that's going to do is give you the start point of the curve. Okay, so you plug the left value of the interval into your function for x, see what you get. Plug the left value of that interval into your formula for y, see what you get. That's your start point. What letter do you think you're going to use to get your end point? B. You're going to take B, plug it into your formula for x. Then you're going to take B, plug it into your formula for y. And that's the end. Okay, so this is the first thing we're going to try to do. I'm going to give you a set of parametric equations. I'm going to give you an interval. And we're going to find where it starts, where it stops. And then we'll sketch it on the calculator. Okay, so we'll practice that a little bit. And I'll explain some things to be careful with on the calculator. All right, so in our problem, the formula for x is x equals 1 minus 2t. Y equals 2 minus t. And we're going to sketch this over the interval from 0 to 1. And really, we're not even sketching. I just want to find the endpoints. All right, so in that interval, what number is going to control where my curve starts?
0.
The 0. Okay, we're going to plug 0 into each formula. We have to find x of 0, and then find y of 0. Okay, so just fill 0 in for t. So 1 minus 2 times 0. That would give me a value of 1. Okay, y of 0. Take 0. Fill it in for t. Corey, what's 2 minus 0? 2. So what would be the coordinate for my start point? 1, 2. Yep. So this curve is going to start at 1, 2. And it's going to end. Okay, what value in my interval is going to help me figure out where the curve ends? Yep, now you use the 1. Find x of 1, y of 1. Okay, so we got 1 minus 2 times 1 and 2 minus 1. Right, so Tom, what's 1 minus 2 times 1? Good, negative 1. And Olivia, 2 minus 1? 1. Okay, so what is my endpoint?
Negative 1, 1.
Yep, negative 1, 1. Any questions on how we got the start point or the end point? All right, let's graph it. Okay, so if you haven't already done so, make sure you're in parametric. Type in, scroll up a little bit. Okay, 1 minus 2t for x. Minus 2t. And for y, let's see, 2 minus t. Now, there's a spot where we have to set our minimum and maximum value for t. Okay, that's under window. What's my t min?
0.
Yep, it's already 0. And my t max? 1. Okay, leave t step on 0.13. This isn't the best problem to show you what t step does. Okay, so just leave it there. And leave your window negative 10 to 10 and negative 10 to 10. Okay, so we get a line segment. If you wanted to see it a little bit better, you could go zoom to. You could zoom in. Let's check our start and end points. Okay, looks like it starts at 1, 2, over 1 up 2, and it ends at negative 1, 1. And something you can't tell is the direction it drew the line in. Okay?
Left, right to left, right.
It went right to left, right? It went from the start point to the end point. You might think, well, it always goes left to right, but if you just change it and then graph it again, watch it as it graphs it. It starts at the right and it went to the left. Okay. Any question on that? So you could try, just to kind of learn, you could try, can you set your T min higher than your T max? Okay, could you do something like that? That's not going to work well. Because you might think, well, how could you make it start and go left to right instead of right to left? And there's ways we could play with that. But it's not switching the min and the max. You can't do that. Okay, so make sure your max is always higher than your min. Okay, any questions on that? All right. And that is a line segment. Okay, that's what we just drew. Right, now, sometimes what we can do is take an equation that has t in it, okay, equations that are parametric, and get rid of the parameter. So in other words, we can change this back to what we're used to doing, like y equals, in this case, it would be a line. So y equals mx plus b. Okay, and if you do that, if you get rid of the parameter, that's called eliminating the parameter. Okay, you will have 2 or 3 problems on the test where I give you 2 sets of equations, and I'm going to want you to rewrite it without a parameter. Okay, so in other words, back the way we're used to doing it. Okay, anybody have a guess how we're going to do that? It's a strategy we've used before. You usually use it when you're solving systems of equations. Some kind of substitution. Yep, we're on the right track.
I was gonna ask if you had to like switch it so t equals.
Yep, you do want to get t by itself.
So you
Which one though?
x.
Yes, you want to get t by itself in the x equation. So how would you do that, Andrew?
Subtract 1 on each side, and then divide by -2.
Divide by -2. Now, if you want, we can deal with this negative in the bottom by doing what in the top? What if I just want to get rid of that negative? What would I have to do to the top?
Multiply by or take out.
Yeah, you could make this -1 or -x plus 1, or just switch the order. This is the same thing. To me, that just looks a little simpler, though. Okay. Anytime you switch the order when you subtract two things, it just introduces a negative, which would then cancel out that negative. Okay. If you don't like that, you don't have to do that. It's just, I don't like having this negative. So I took care of it just by switching the order and getting rid of it in the bottom. Just a little calculation trick. All right. Now, what am I going to do with 1 minus x divided by 2? Where? Yep. Do that, and then we'll have a new equation without a parameter. 2 minus, and put it in parentheses. And the other thing I'm going to do is write everything as a fraction. So I'm going to put 1/2, and then x divided by 2 is 1/2 x. Okay, and then what do I have to do with the negative in front? Yep, distribute it. So y equals 2 minus 1/2 plus 1/2 x. And what's the last thing I could do?
Combine like terms.
Yeah, combine like terms, and I'm also going to put it in y equals mx plus b. So it's 1/2 x, and then what's 2 minus 1/2? 1.5 or 1.5 or 3/2, however you want to write it. Okay. So any question on that? So the idea here is to use substitution. Get t by itself in the x equation. That's supposed to be a t. Get t by itself in x equation. Then plug the result into the y equation. Then plug result into y equation. Okay, so what we just did. All right, let me take what we have right now and let me put that on the screen. And then I'm going to graph this and we'll compare the two and see if they look the same. Let me come back to that in a second. So that's what we have now. Okay, and now I'm going to change it back to function. And I'm going to graph y equals, what was it? 0.5x plus 1.5. To function. And if you change back and forth, your functions will stay in the mode. So for example, my parametric equations are still there. Okay, even though this screen is blank, if I go back, they'll pop back up. So 0.5x. What was the y-intercept? 1.5. Thank you. I'm going to hit graph. Let's compare that to what we just had. Okay. So are those the same? This was the parametric. Actually, does it say it up here? No, it doesn't say what mode we're in. And this was function. Okay, same graph. What's different about the function one?
It's continuous. Right. Just a line, and it just goes on forever.
Right. The domain here is negative infinity to infinity, so it goes on forever. So all we really want is part of that. Okay, so what we have to remember is that the original curve we drew, it was only a small segment of that picture. So we have to account for that. So what I have to do is restrict my domain. Yep.
Mine isn't like that. When I do the regular parametric one, mine like has a start point or end point over here, but then it just continues.
It just continues. You want to try it? Why don't you try the one that...
Do you have a t-step right? Because I changed the t-step back to the default. Okay.
You could try resetting your calculator. You could try that too. If that doesn't work, let's look at it after, or you can borrow one of mine for today. But let me know. All right, so where was this? Does anybody remember what was the start point and what was the end point? Where was this curve supposed to start? Specifically, all I care about is the x. What was the lower value for my x? Okay. -1. And what was the higher value? 1. Okay, so really, all I want to do is graph this picture from -1 to 1. And here's how you do that. Put it in parentheses. And then tell it you want x to be greater than or equal to -1.
Greater than or equal to.
Right, we had the bracket. So I want greater than or equal to -1. But I also want x to be less than or equal to what? 1. Now, what it's going to do is everywhere that it is not between -1 and 1, it's just going to trace along the x-axis. I can't fix that. But we should only see this part sketched on the screen. Everywhere else, it's going to sketch blue on the x-axis. Right? So let's see how that works. And that's as good as we can do. All right? So that's how you can sketch a part of a function. Just remember to put it in parentheses, both the original and each condition. I don't think you can do a compound inequality here, like x in the middle, and then put -1 on the left and 1 on the right. I think I've tried it and I had trouble with it. But if you want to try it, you can see what happens. Okay. Okay. Any questions on that idea? Remember, if you remove the parameter, you have to write the domain. Okay, so even if the directions don't say to write the new domain, it just says eliminate the parameter, you have to give me the domain. That's part of eliminating the parameter. All right, so let's try it here and see what happens. Okay, so step 1, solve your x equation for t. Evan, what will t equal if we rearrange this top equation?
X plus 1.
Yep, x plus 1. And DJ, what do I do with that x plus 1?
You plug it into y.
Plug it into the y equation for
T.
t. So my new equation will become
X plus 1 squared.
x plus 1 squared. Perfect. Okay, so that's half of it. We have the equation. Who can tell me what is that shape when you sketch it? It's a parabola, but what have I done to it? What's this plus 1?
You just it up 1. You moved it left.
Not up 1.
You moved it left inside.
It's inside, so it's the opposite, so it's left 1. Okay, this is a parabola shifted left 1 unit, but is it an entire parabola or was it restricted? It was restricted. Okay? So I have to figure out the domain for x. what's going to be, and again, think back to your original equations. How am I going to figure out the x value of my starting point? What number do I plug in and where do I plug it in? Plug 0 in for t, where? Remember, just the x. Okay? I'm not asking you for the range here. I don't know. I don't care how high and low this is going to go. I just want to know left to right. So what's going to be my starting value for my x coordinate of my starting value? Okay, so take 0, plug it in for t, 0 minus 1. So that's as far to the left as we're going to go. And then how about to the right? 2. Take 3, fill it in for t. 3 minus 1 is 2. Now, if I did ask for the range, what's the lowest and what's the highest this function goes? Zero to 9. Yep. The lowest value you can plug in, the lowest result you'd ever get is if you fill in 0 and square it. The highest result, 3 squared, would be 9. Okay. Any questions on that one? All right, so that's eliminating a parameter. Now, that's not always possible to do. Okay, I gave you examples where you could do it. So it's not always possible to take equations and get rid of the parameter, but it is always possible every time to go the other way. You can always take something that's not parametric and make it parametric using these simple equations. And let me show you how this would work on the last problem. Let me take the result we had and let me make it parametric again. But I'm not going to do it the way that it was given to you. I'll show you a different way to get the same picture. So we'll do another one after. Y equals x plus 1 squared. Let the first equation be x equals t. And let the second equation, y equals t plus 1 squared. This is another way to write this parametrically. Okay? You might say, well, how does that work? Well, step 1, if we were going to change it back, solve this top equation for t. It already is. What does t equal? Just x. So now you would take and substitute that in everywhere you have a t. And if you did that, you'd have y equals x plus 1 squared. So it's kind of a cheap way to make something parametric. But it works. All right. So you just let your first equation be x equal t, and then basically change all your letters to t's. Okay. This would be a little harder, I think, to come up with on your own, but maybe some of you could get that. It's exactly equivalent if you graph what I have here and here. They'll come out the same. You might have to adjust your interval to make it look the same, but they are exactly the same sketch. Okay, in fact, here I think the interval would probably be from -1 to 2. If you did, I think if you did that interval, you'd get, let's see, 9 would be your maximum height, and 0 would be your minimum height. And your farthest left value would be -1, and right would be +2. Right. So keep in mind, if you change your equations, you might have to change your interval. All right, let's try that one. Okay, how could I write that parametrically? What would be my first equation? Just let x equal t. And how about my second equation?
Change all the letters to t's.
Yeah, just change the letters to t's, and again, it's a cheap way to make something parametric. But technically, it counts. And I can always check it by following the steps. Take the top equation, solve it for t. It already is. Substitute in my result for the variable. And that would just change all my t's back to x's. Okay, so you can always take anything and make it parametric, but you can't always go the other way. Any questions on that? I don't really see why you would want to do this, because I think it's simpler as a function than it is parametrically in this case. But that you can do that if you want. All right, so we've looked a little bit at graphing maybe a parabola, part of a parabola. We did a line segment. Let's look at a circle. Okay, so we're going to find the parametric equations for a circle. And the way we're going to think about it is how could you represent any given point on the circle by itself? Anybody have a thought what it's going to be involved here? Yeah?
Degrees? Like the amount of degrees on a circle?
Okay, degrees and radians is going to be a very important part of it, and that's where I'm going to show you what the t-step does. What else? What do you think I'm going to have to maybe sketch in this picture?
A right triangle.
Yep, I'm going to make a right triangle where the hypotenuse is going to go from the point to the origin. All right, let's start with that. Can't find my vertical. There we go. Right, let's call that my radius. Okay, the hypotenuse is the radius of the circle. How long is the bottom side? X, and the height? Y. And now I have an angle, but usually we use theta, but since we're going to do it parametric equations, what do you think I should use to represent my angle?
T.
Yeah. T. Okay. Now I'd like to come up with a formula using t and maybe a trig function for x, and then I want to come up with a separate formula for y. Okay. R is not a variable here. Remember, R would be fixed. They would tell you the radius is something. Yep. So R would be a fixed value. So what trig function would we use for x? Yep.
Cosine.
Okay. So what would you write? Cosine of
T.
t equals?
X over
All right. And if you solved for x, what would you have?
R cosine.
R cosine t. And remember, this is a function in terms of t. R is not a variable. It would be fixed. Okay, so based on that, anybody think they can tell me what y of t would be? So yeah, if you use sine, sine equals opposite over hypotenuse. And rearrange it to get y by itself, and you get r sine t. So that's how you draw a circle parametrically. X equals r cosine t, and y is r sine t. Just fill in whatever they tell you for r, and that's it. Right. So what would be my equation of a circle centered at the origin? I'll show you how to shift it after. With a radius of 2. Okay, what would be my x equation? 2 cosine t, good. And 2 sine t. That's it. Right, so let's graph it. Okay, see what happens. Okay, if you switched over to function, you got to go back to parametric for this. All right, so we got 2 cosine t and 2 sine t. All right, what should I set for a, let's start with a window. We have a circle, radius 2, centered at the origin. Yeah, I'd say -3 to 3 on each axis. Now, keep in mind, is your screen, is it a square? No, it's a rectangle. So if you have basically -3 to 3, that's 6 units left and right, 6 units up and down. Is it going to look circular? No, it's going to look more elliptical or oval because you're cramming 6 units into the same space horizontally and vertically, but you have a wider screen horizontally. So if you wanted it to look square, you'd have to figure out, it'd be a little tricky to get the right numbers, but you could do it. You'd have to find the ratio of the length to the width. All right, now t is the parameter. If we do this in, let's do it in degrees.
360.
How many, what do you think we have to go through for a minimum and a maximum value? 0 to 360 is perfect. The point is you've got to go through every value before it would repeat. Okay, that's 0 to 360. Okay, and leave t-step at, actually, you know what? Let's set t-step at 5. I'm going to show you what that does right now. Okay, I'm just going to hit graph first, and then we'll talk about the t-step. And there's your picture. Yeah, again, radius is 2. Just count the tick marks. But it's because the screen is wider than it is tall. All right, now the t-step. What the t-step is, it tells the calculator how often to graph a point. So this calculator, what it's going to do is graph every angle from 0 to 360 going by 5s. So it's going to graph, plug in 0 for t, then 5, then 10, then 15, then 20, then 25, all the way up to 360.
What would it look like if you did like 20?
Well, this
So-
one happens with 20.
What would happen if you did 20? It's not going to graph as many points. So your circles, it's going to start to have some edges that are, it starts to get a little choppy. Okay?
Do like
Because you're only,
460.
does everyone see what's happening?
Yeah.
You're only graphing 0, 20, 40,
So if you did
60.
180, you only have 2 points.
Yeah, if you did 180, technically you'd have 3 points. You'd have 0, 180, 360. But the start and the end point would be the same.
So do like
It
one.
would just be a line.
Do 179.
So if you did 180,
179.
all you'd get is a line.
Yeah, do 139.
1, 2, 3. All right, well, yeah, let's think about, let me show you what happens first, and then we'll do 179. If I did something like 50, okay, it's going to graph 0, then it's going to graph what? 50, 100, 150, 200, 250, 300, 350, and then there's 10 missing because the next one is 400. It can't do it. So what ends up is we have a little gap. So try to pick a t-step that's a multiple of the t-max. So if you do 179, okay, what would happen is it's going to graph 0, it's going to graph 179, then it's going to graph 358, but can it graph the next one? No, so you might not see a gap in this one though because it's
Do
already
like 175.
already traced.
So close.
Even if you did all the way down to like
170.
91, I think even that would look the same. No, I lied. Like 150, let's see. All right, so you're getting a point, 0, 150, 300, and then you have a gap here of 60 degrees I couldn't do. All right? So the point, pick a t-step that makes it look
Good.
pretty good, yeah.
Make it 0.
So what if I did 10? How many points would it graph?
36.
Keep in mind the end point and the start point are the same point. So it really graphs 37.
Oh, that's right.
Okay, it's going to graph 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's 11. And then it'll graph. Keep going from there. Okay, on a test, I would say a t-step of 10. If you wrote that down, I would accept that. That's fine. If you started to do a t-step of like, let's say you did 36, that's not really what it should look like.
So why don't you just leave it like 0, 1 all the time?
Well, the problem is if I leave it at 0.1, in this case it would graph 3,601 points, and the calculators, it's going to slow way down.
Just do it.
It's going to be almost not moving.
To just calculate the increase in speed.
Yeah, so it's probably going to take 2 minutes to draw it.
Almost
Well, we
identical.
gotta sit here and wait. Watch
It's
it.
gonna be so perfect though.
You want to wait? You want to wait for it,
Very
Graham?
accurate.
Yeah, that's good.
So even speeding it up 4 times as much doesn't really help.
I was doing quite a bit.
Hang on, whoa, it's almost, it's getting there.
It's getting there.
You almost got it up to me.
I think it was at maximum.
Wait, do custom.
That's maximum. That's it. That's all I got. She's got no more power.
That's
all she's got.
Igor, we need more power.
More power.
We made it halfway.
So say your t-step reasonable. I'd say if you did, I'd probably go like 2 at the lowest. That's going to be way more detail than you need, but it's okay. Okay. And you could try different things. You could try what happens if you switch the sine and the cosine. Is it still a circle? Does it change? You can mess around with it. All right, so what was the domain for our parameter? The window was -2 to 2, but what about the domain for the parameter? It was our minimum value and maximum value. If I only graph -2 to 2 on the parameter, I would probably only see a very, very small portion of the circle.
180, -180.
We didn't do that, but you could. That would work. What did we do?
0 to 360.
We did 0 to 360. What would the difference be if you did 0 to 180? And I'll give you a hint, it's not in the final picture.
It's the start point.
Oh, there's so many
The
circles.
origin is
Just
just
the line.
like the beginning is different.
The beginning and the end are different. Okay, watch this one. You can only see it if you watch it, not when it's done. I need to change something to make it. Notice where it starts. Okay, it starts on the right-hand side. If we change it, Brad, what did you say?
-180, 180.
All right, let's try -180 to 180. Okay, I'm going to put that up a little bit. Where do you think it's going to start now?
The last one.
Yep, it's going to start on the left side and it's going to end back there. So same picture, different parameter. Now, what if I went, say, 0 to 720? What's going to happen there?
It's gonna go around twice.
Yeah, it's just going to go around it twice,
Oh, I thought-
and you're really not going to see anything after it goes around the first time.
She's still working.
Still going around, and it just finished. Okay? So another question I could ask you is, what's the minimum parameter you could have to go all the way around this and make the shape I'm asking you to make? In the case of a circle, it's 0 to 360.
What if you had your step up at like 150 when you went around twice?
Well, then you'd get points at different spots. You can try it and see. So you're going to get 0, 150, 300, 450, 600, and that's it.
So it's just gonna start.
So you're going to get something where they might cross over each other a little bit, like a star. You know, that's.
Make a butterfly.
How do you make a butterfly?
I don't know, it's right.
And if you kept going, eventually you probably could make a full star, or you could, like, let's say you went all the way to.
1040.
Let's do. So it's really a circle right here. It just now it looks a little different. And you also, another good question, or a bit of hard question, would be to figure out what's the radius of this shape inside that.
Probably not do that.
That'd be a tough question. Figure out the radius of that inside there that's formed by all those crossing segments.
Actually, you can go out that.
It looks like an ellipse to me, but I'm not sure. I can't prove that.
It's
Well,
just,
because the screen's.
Because remember, the sides here are really straight, right?
so how would you go about doing that?
I don't know. I'd have to think about it a little bit. That'd be really, really tricky. No, we're not going to figure that out today.
Or Friday, or ever. Or the next day. Or the next day. Or the next day. Or the next day.
And you'd have to think of it as having your parameter go to infinity. So then the sides of that shape in there would be smooth, not like blocky. All right, so let's try graphing this and just getting a complete graph. So for a complete graph, what I want to know is the x min and max, y min and max, t min and max. All right, what do these equations look similar to? No. Kind of like a circle, but what do you notice about the radius?
It's also T.
It's also t, and t is a parameter which changes. So this is a circle with a radius that's constantly changing, which is what kind of shape?
Spiral.
A spiral, right? It's getting further out from the center as t gets bigger. Right? But there's a limit on the spiral. We're only going up to 4 pi. So if you just think of the graph of cosine. What's the highest cosine ever hits? 1. And if you multiply that by the biggest number we can hit, which is 4 pi, what's 1 times 4 pi?
4 pi.
Okay, so we know the biggest x value you could ever get is 4 pi. All right, so let's set that. 4 pi. Now, yes, I got to switch to radians, thank you. What's the lowest cosine hits?
Negative.
-1 times the biggest value we could have for t is 4 pi.
Negative 4 pi.
All right, so we know we're between -4 pi and 4 pi for x. Let's make that negative. Well, you can just type in 12.56. That'd be close enough. All right. How about for sine? It's the same thing because sine hits a maximum of 1 and a lowest of -1. Now this is like maximum. Okay, we're probably not going to need a window as big as we have because it's a spiral. So one side of the spiral is probably going to touch the edge of the screen. The rest of it is not. Okay. So let's go -4 pi and 4 pi.
Wait, that's the x.
Thank you. Okay, and I'm going to switch to radians.
You can do the y max.
Why did you change your x?
Yeah, you change the x.
Oh, did I change? Whoops. Just leave that the way it was. I think it was just that one.
Just change the.
Wait, you changed the y min.
Thank you. How's that?
That's better.
Not as accurate.
All right. Now, what about the t min and max? What was the min?
0.
And what's the max for my parameter?
4
4
pi.
pi.
Which we already know is 12.56. T step, what should we use for that?
Yeah,
2.
Yeah, 0.1 wouldn't, well, keep in mind, when you do sine and cosines, those are a little more complicated. So maybe 0.5. So that way it's basically, if you think of 0 to 12, that's like 25 points it's going to graph.
Oh.
And, oops, did I type in the equations yet? No. T, cosine t, and t sine t. Now graphing.
Cool.
Okay, little blocky. I'd say maybe,
0.25.
yeah, maybe doubling the number of points. That would be a good idea. And that should look fine. That looks pretty smooth. I don't think you're going to get it much smoother than that on the screen. What's that?
Looks like Gary's shell.
Yeah.
Actually, maybe it doesn't go the other way.
It goes the other direction.
Yeah, so.
Okay, so any questions on that one? So there's your T-mins and T-maxes. All right, let's try that one. Okay, so this time, if you look at x, does it have a maximum and a minimum value?
No. Yes.
Yeah,
25.
5 would be the maximum, and what about the minimum? Negative 5. So the x's are bounded. Okay. How about the y values? What does cosine go between?
5t.
Sine is sine, which is 1 and negative 1. But then you're going to multiply that by 5. So 5 to negative 5. But then you're going to multiply it by t.
So it does not have
So it constantly changes.
Wait, what is x?
So yes, y is constantly changing. So now we have one dimension that x is going to stay this bounded. Y is unbounded except for the maximum value of the parameter. Okay? And we used cosine with a circle for x. So now this is sine. So this is a tough one to figure out what it's going to look like. Let's just try it. So what did we say for x? Negative what to what?
Negative 5.
Okay. So negative 5 to 5. And this is negative 5 to 5, but then you could multiply by the maximum value for the parameter, which is how much?
20.5.
So let's say about 20. So what's 5 times 20? 100. So, and it's 20.5, so let's go like negative 110 to 110. Negative 110 to 110. What's the minimum value for my parameter? 0, max? 20.5. What about t-step? Yeah, I think 0.5 is good. If you went 0 to 20, going by 0.5s, it's going to graph 41 points. So that's probably sufficient. And type it in. 5 sine t. And what's the other one? 5t cosine t.
And it's also raining.
Okay. Before we graph it, does anybody have a thought what this one's going to look like?
It's going to be square.
It's going to be a butterfly.
A butterfly?
Butterfly.
Not quite as interesting, but it is a little different shape.
It's not a spiral.
It's a watermelon.
It's a watermelon.
Yeah, it kind of looks like a watermelon.
It's a watermelon.
So notice what's happening is left and right. You're never going to go beyond negative 5 and 5. But up and down, you go all the way up to 100. The higher you set the parameter, the more it's going to go up and down. It's not going to go any more left and right. Okay? And honestly, I would probably set the t-value maybe a little higher. I think 0.25 would make it look a little smoother.
What does that mean?
It's not quite as blocky.
Could you like compress that at all by like changing like 5 to 2
Yeah, let's think if you change the 5, it wouldn't
to a smaller?
be multiplied as much, so
So that would compress.
that would compress it a little bit.
Make it fat.
So you can play with it and kind of do different things.
Maybe like
We could also shift it. Let's say you wanted to shift it, I don't know, let's shift it 2 units to the right. You could have done this with a circle too. So you might say, well, wait, doesn't a +2 shift up? Not if you're separating the x's and y's. +2 on the x is going to shift it right 2 units.
I thought it was only the opposite.
No, not with parametric.
Oh, great.
That's just going to take it out face value.
And what if you wanted to shift it down 3 units?
-2.
Yeah, you probably wouldn't even notice -3 because remember how big the window was? Let's shift it down 50 units.
Wow.
Now it's shifted down. Okay, so shifts are very easy to do. You just add or subtract whatever you want to shift it by right to the end. Okay? All right, let's try one more. Mhm. Yep, sign up. Okay, let's find this one. Now, is x bounded? Like, let's say t can be as big as you want. Will there be an upper limit on the size of x?
No.
No, because you're going to have, let's say t was 1,000,000. 1,000,000 times 5 is 5,000,000 minus, what is the thing that I just circled? It's always between what and what? Yeah, -5 and 5. So you're going to have a huge number, plus or minus 5. Doesn't even make that much of a difference. How about y? Does that go as high as you want?
No.
No. This is always between what?
Negative 5.
-5 and 5. So you're always going to have 5 plus or minus 5. So 0 to 10. Right? I think that's as high as you'd go for your y values. Right? 0 to 10. So let's try that. So window, let's go. Wait, could you go higher than 10? No, you can't go higher than 10 on the y side. So 0. Let's just go to 12. And then x is really, depending on the size of the parameter, can be as big or as small as you want. So let's try -200 to 200. And let's do the parameter from -30 to 30. Because they didn't specify. So let's, did I type it in? 5t minus 5 sine t. And 5 minus 5 cosine t. Okay, any guess what this is going to look like?
An elephant.
An elephant? Not quite.
Flower.
Ooh,
A
I
flower.
like flower.
That's just because of where I started my parameter. I started it in the middle of a thing.
So it's like a cone.
It's grass.
It's a
Grass.
It's a
Well,
cone.
maybe we should turn it to green to make it grass.
Oh, yeah, change color.
We could. All right, so basically, at this point, you don't need to show anymore. It's just doing the same, just doing this kind of bouncing along kind of thing. Okay, that's all it's
It's
doing.
like a bunny rabbit.
Okay, so there's our values.
Shades of gray.
And let's take a look at this first part. What could you factor out of the first term and second term here? A what? And if you did that, what would you be left with?
T minus T.
Okay, and what can you factor out of the y's? And what would you be left with there?
Negative cosine T. Right?
1 minus
Oh.
cosine.
Yeah. And I want you to kind of focus on this pattern here. Okay, anytime you have a graph where it's a number times t minus sine t, and then a number times 1 minus cosine t, that is a special graph. Okay? That's called a cycloid. Okay, let me get that picture of the cycloid back up. But you know what I want? I want to stretch it out a little. So I'm just going to look at, let's look at -75 to 75. See if that gives me what I'm looking for. Now keep in mind, it's drawing the parameter off the screen, and then all of a sudden it comes on the screen. That'll be good.
Golden arches.
Yeah, they're yellow.
It's like
You gotta put it upside down.
Okay. Now, what I'm going to do is I'm going to take that cycloid and I'm going to flip it upside down.
Make it negative.
Or you could just do that.
Okay. And I just want to focus on one section of it. Okay, so I'm just going to try to block the rest of that out. Let's see if I can do that. Okay. And right. So just focus on that one section. Let's just group all that together. Right. If you had an object, say right there, like a ball, okay, and you were going to drop it and let it roll down to that point. Okay. If you take a cycloid and you flip it, okay, the shape of this curve is something special. basically, it gives you the fastest curve for the ball to go from this point, dropping down to this point. There's no faster way for the object to stay in contact with a surface and get down to that point. That's called the curve of quickest descent. Right? So like if you put a plank like that and just let it roll down that, it would be slower. Or if you tried, your curve a little differently, like that curve wouldn't be as fast.
We test
Okay,
this.
that's the curve of quickest descent.
Yeah, how do we test this?
We'd have to build different kind of ramps from a high point to a low point and drop objects and see what
Alright, let's
happens.
do it. Tomorrow.
And you'd have to engineer the ramp in exactly the shape of a cycloid. So
We
Yeah,
gotta
but I can
like,
do the.
you just have to print out a picture of a cycloid and
There's no way we're gonna use.
model it right after that.
I'll wire it. We don't have lights on the side.
I can kill people. They
I'll
can
make
do
designs for it, just have a good crew.
Okay, so any question on that idea? Okay, so a cycloid is the curve of quickest descent. So not something too important, maybe a bonus or something with that. But- Okay, any questions on parametric? Okay, so tomorrow we'll look at the last mode that we're going to use, which is polar.
Oh, what's the last one?
What's sequence?
I haven't used the last one, I'm not familiar with it.
Never use sequence because that's what it looks like.
But polar is pretty nice, for example, if you just want to draw circles. Okay. Or if I hit zoom 5, now it looks like a circle. Okay. Circles, very, very easy to draw in polar. Lines, not so easy. Okay.
Can you do it?
Try.
Maybe tomorrow I'll show you how to do a line in polar, if we have extra time. All right, so homework, a lot of graphing, so make sure you have your calculator, and some of it's just writing windows. So on 481, try 1 to 5, 7, 9 to 11, 13, 15 to 17, and it kind of skips around, 21, 22, 25, 26, and 29 to 33. Okay, some problems you'll remove the parameter, some you'll write things parametrically, a little bit of graphing, and finding start points and end points. Okay, and we'll go over that tomorrow.